Hi, I'm Bob Fornell. I'm here to talk to you about what to avoid when writing unit tests. Good unit tests are a critical part of the development process and vital to the life cycle of code under test. With a previous employer, I had a case where we had no tests. We weren't allowed to write tests. There wasn't enough time. The result in that case was flaky code, the code that didn't stand the test of time. In another scenario, positive, I had to write a script language to replace a language that was on a mainframe in a browser. The language was about 180,000 lines of code. We had 97% unit test coverage over that code. These unit tests were in depth. Anytime we found an issue with the code, I was writing a test, checking that it failed, and then running the test suite once I had fixed the code, a TDD pattern. So the value of unit tests. Over the next year with that code in production, we had 3 bug cards that came up. 2 of those were missed requirement issues. Other cases that I've run into, a developer that had written 2,000 plus unit tests against promises within his JavaScript code. These tests passed even when the code failed. We had no or limited unit testing in some cases because of monolithic code that we've seen. 3,000 to 6,000 line functions. I mean, how do you even write unit tests against that much code? So I want to reiterate that good unit tests are a critical part of the development process, and they're vital to the life cycle of our code under test. So, what are unit tests? Unit tests exercise small parts of the application in isolation. They compare the code under test's actual behavior with its expected behavior. The complete isolation part that we talk about means that when the unit tests are being run, we don't typically connect the application with external dependencies, databases, file systems, HTTP services, whatever. This allows the tests to be fast and be more stable since they aren't going to fail due to problems with external services. Each unit test is like a specification or an example of how that part of the code should behave in certain scenarios. By executing the suite of tests, developers can get immediate feedback when they make some change to the code base. So you're here at this talk. The code repository is listed up here. This is the GitHub repo. Bob-Fornell is my account, and the title of the repo is What to Avoid When Writing Unit Tests. I do have code we're going to go over that should be fairly easy to find if you can find my repo in general. I can be found at linkapp.com/conference. My contact information is there. I'm also out on Twitter at rfornell. Have many articles, several topics. Unit tests are included there on DevTO. Then my LinkedIn account is listed up there as well. One of the side topics I'd like to discuss is I am involved with 100 Days of Code from the AWS training I'm doing. There's also 100 devs that I'm involved with. And one of the things that I would like to ask is that if someone viewing this can hop out there onto Twitter, search one of those hashtags, find somebody in there, 1, 2, 3 people, preferably somebody that's in your field. So if you're working on Python, if you're working on front end, whatever, find somebody that's in your field, especially if they haven't had a response on a post that they're putting out there, and go out and cheer them on a little bit. Nothing big, just something that I do to help out newer developers. So, testing code has been described many times, as I've heard it, as an art form. Okay? It is an art form in some ways, but it shouldn't be. There are many good patterns that should be followed when writing unit tests. There are also many bad patterns that you should be aware of, so that they can be avoided, so they can be cleaned up. And this is really the core to where this talk is coming from. Good production code achieves encapsulation. Okay, it allows the reader to navigate large systems easily, diving down into the details, coming up to see higher levels of abstraction as needed. Okay, but test code is different. It's a different beast. A good unit test is often small enough that a developer can conceptualize all the logic at one time. You can read through it quickly and see what it's about. Adding layers of abstraction to test code increases complexity. We don't want to do that. Tests are diagnostic tools, so they should be as simple and obvious as we can make them. So tests should not be well factored, and just to define that, we need to talk about what well factored code is. Okay, so well factored code is code that's easy to read and reason about. Code that can be tested easily, and code that's well defined often has a high level of complexity. Okay, so our day-to-day code, where we've abstracted things out, where we break things down, where we break things up in a way that then makes it easy to figure out what's going on, isn't necessarily what we want to do for unit tests. So here we talk about some examples, keeping the reader in the test. We don't need to be jumping around to multiple files to figure out how the tests worked. Okay, in this case, we want to dare to violate the dry principle. We do want to repeat ourselves quite often in unit tests. So when I talk about keeping the reader in the test, okay, think of rulers, just typical 1-foot ruler. They've existed in the same form for hundreds of years. They're uncomplicated. They're easy to interpret. Okay, if we invented a new ruler that measured in abstract ruler units, to convert from ruler units to inches or centimeters, you'd have to have a separate conversion chart. Okay, if we gave that ruler to a carpenter, I'd probably get hit upside the head with a ruler. Okay, I actually have that in my notes. This layer of abstraction is unnecessary to a tool that is clear and easy to understand. Okay, so I have code here we're going to take a quick look at, and what I want to point out is that the code we're going to look at, the broken code, is not necessarily bad. It's just that it could be better. Okay, when we write a test, when we write code, we should always be thinking of the next developer who gets to see the test break. Okay, they don't always want to read the entire test suite. They certainly don't want to read and dig through an inheritance tree of test utilities to figure out how the test works. If the test breaks, the reader should be able to diagnose the problem just by reading through that one test function. Okay, straight line, top to bottom. They don't have to jump out and look at something else. Okay, if they can do that, the test has done its job. Okay, so let's take a look at some code here and what we mean by keep the reader in the test. So looking at this code, this is the broken example. Okay, and I'm going to widen this up just a little bit so we can see the titles. And we have this class manager. Okay, manager through the constructor takes in a database value and assigns it to this.data. Okay, and then we have two functions that are fired here, so a get score function and adjust score. And I wrote these to fit the screen well. Nothing too complicated here. They could have been simplified, certainly. Okay, but where we need to focus is on the test suite. There's nothing wrong with this test. We have a before each that sets up this database that we're going to pass in, passes it into a newed up manager. Okay, we didn't create a mock here. Had we created a mock, we probably would have killed the whole reason for doing this. Okay, but then down here in our test, we expect a score of 200. We get an initial score from sending it in Bob 54321. Now this is short enough that seeing the score as 200 is right here. Okay, but if this test suite had been hundreds of lines long and this is down towards the end, where did this 200 that we expect come from? Okay, this is not broken. This is something that we need to adjust a little bit to keep the reader in the test. Okay, so if we look at the fixed example here, in the fixed example, it's the same code up top on the manager. In the fixed example, we expect the score to be 200. Now, we set up the database here, and you can see we've got a score of 200 over here. As we pass that in, we have the manager got defined. We set our initial score, we set the initial score by getting the score for Bob 54321, which I can clearly see that somehow goes back and gets that 200 because now we're checking for initial score equal to 200. Okay? Nothing majorly complicated there, just keeping that reader in the test as frequently as we possibly can. So, dare to violate the dry principle. For strict adherence to the dry principle, the code we're going to see here is really bad. Okay, we're going to blatantly repeat ourselves. We copied lines from previous tests. Worse, we can argue that dry violating tests are better than tests that are free of repeated code. Well, we just talked about that. We want to keep that reader in there. We want to keep them seeing everything it takes to make that test run. Okay? If we can achieve clear tests without duplicating code, it's ideal. But having non-redundant code is a means, not an end. Okay? The end goal is clear, to keep the tests simple. So before we blindly apply the dry principle to our tests, think about what will make the problem obvious when a test fails. Refactoring may reduce duplication, but it also increases complexity and potentially obscures information when things break. Okay, so in this case, on the dry principle, let's go take a look at some code. So looking at the broken code, again, we have the manager class. Hasn't changed, same thing. Okay, so let's take a look at the violating the dry. Let's take a look at this describe down here. Okay, so we set this up to run the same way we did before. We had the before each on the broken one up above, keeping the reader in the test. Okay, we have the same broken test here that we had in keep the reader in the test, but then down here, when we want to go to test the adjust score, we pass in the bob54321 to that function, and we're passing it the value of 500, so that if we fire this initial score again to get a score, we have 500 come back. We didn't repeat ourselves because we pulled this code out up here into the before each. Okay, so again, we're violating two of our principles. We don't keep them in the test, and we used the dry principle. Okay, so let's take a look at this fixed and see what that means. So, same class manager, but down here we're setting up the database, and we're setting up the manager, the service, the exact same way we did before. And if you look, we're doing the same thing here that we're doing right here. Okay, there's no difference between those two sets of code. We duplicated code, which in our regular code is fine. The code under test. Within tests, it's better to have that code duplicated. Better to make that more readable, more understandable, cleaner, easier to figure out what's going on when something breaks. Okay? So let's go back to our slides here. And the next one. See if we can get through this without speaking the words incorrectly. Poisoning the code base. Non-deterministic factors. So in this case, we have tightly coupled data that can make testing challenging. Okay, if we make an assumption that our code under test uses the current date or time, okay, to generate some string value. The current date is a concrete data source. Okay, and what we see here is the code gets the date and generates the string. It's doing two things. Okay, we have that non-deterministic factor. It's a factor we can't determine what it is ahead of time. If we look at the code, this example becomes much clearer. So let's take a look at this on the broken code. So here we have a simple function that gets the time of day. Okay. To do that, we get the date. It's a new date. This is pretty simple to understand, and we need to get the hours off that, which ranges from 0 to 23. We run it through this weird if block to determine night, morning, or afternoon, and then we have a default evening if it's 18 hours or over on military time, 18 to 23. Okay, pretty simple what that's doing, nothing too complicated there. But then, because this code is poisoned with this non-deterministic date time, we have to do all kinds of weird contortions with the clock and setting a date time, and then stepping forward a little bit after we do the mock date, and then checking to see what our get time of day does. This is a manageable test. You can kind of see what's going on in there, but you can see that there's a lot of setup, a lot of things that have to happen for us to properly test this. Okay, so how do we not poison or get time of day? Well, it's fairly simple. We pass in the hour. We calculate that date time external to this function. Because we're calculating it external to the function, we're only passing a value in this test is really only doing one thing. It's taking an hour and returning which category of the hour you're in. And then you can see in our test that really easily we can write a single test here that passes the number 1 and should be returning night. And we could probably write a couple other functions to check each of the if branches if we wanted to fairly easily. But you can see how we just took that complexity of that tightly coupled data out of the equation. Okay. So let's go back to the slide deck here, and we're going to take a look at the next one, which is another poisoning. Okay, poisoning the code base with side effects. Okay, in this case, we're going to take a look at some code that assumes a class that turns a light on or off at certain times. Now, potentially, the light might get turned on or off based on motion. Okay, so again, we're tightly coupled again because we have a date and time in our function within the class, and we're tied directly to an additional class that allows the light to be actually switched on and off. This is just a class that determines whether it should be turned on or off, doesn't actually do the switching. So let's take a look at our poison code with side effects, and first thing I want to dig through a little bit is not the tests here, but the switcher. So the switcher class up here that we then do up has a turn on function and turn off function. You can see they're really complex. We're working with some really complicated code here. Where we have our problems is in the smart controller. Okay, we have a last motion time that initially sets to the current date time. Okay, we have a get daytime function, or sorry, a get time of day function that takes an hour. We've seen this before. Shouldn't be too hard to understand what's going on there. In fact, it's using the newer pattern. Okay, where the problems come in is with this actuate light. Okay, and the actuate light takes a motion detected. It's a Boolean value, true or false, would be our assumption here. I'm not using TypeScript, so I can't say, but I'm going to assume that's what it is based on the name. Okay, here's our non-deterministic date and time. We need to get a date, we need to get a time, and we'll see. We probably have some ideas what we can do to fix that. And then we check to see if motion's detected. If motion's detected, we set the last motion time to the current time. Okay. We get a time of day using our time of day function, and we had to do our date get hours to pass that over to the time of day. And then if motion's detected and the time of day is an evening, or the time of day is a night, we want to turn the light off. Or sorry, we want to turn the light on. Else, we really didn't need the else if, but else, if the time minus the last motion time is greater than 60 seconds, 60,000 milliseconds, or the time of day is morning or noon, we want to go ahead and turn the light off. Okay? And you might have some idea what we're going to see here in our test, but let's open this up and take a quick peek. We have a huge setup to accommodate our date-time function, right? So we have to not just give us the date and time information, but we have to set the last motion time as well as the current motion time. So we're mocking to set the current motion time, and then we set the last motion time on our controller, which was already set up here. And then we have to spy on our turn on, turn off. Remember I talked about the side effects that make it hard to test. Okay, we have to spy on these things, and in this case we're stubbing them out. We could pass through, we want to stub them out. And then we actuate our light, passing it a motion false. We want to see if turn off got called. Okay, so we pass it a false, we have current date and time, we have a last motion time, we set things up so that it would turn the light off. Okay, down here in the next test we're passing it a true, and we've got a different set of date and time values that in theoretically should turn the light on. Okay, it's even difficult to figure out what this is going to do because I'd have to take each of those data points and walk through my actuate light code to figure out what's going on. Okay, really complicated to follow that logic through. If you want to follow that through, go ahead and pull the code base down. It actually does work. So let's take a look at a fixed version of this. Okay, again, I'm going to minimize that describe real quick. We have the same get time of day, we have the same last motion, same switcher. We now have this new function for get time and get hours that we could test independently. Okay. We also have the actuate lights, which then takes in now not just motion detected, but the turn on and turn off function. So when we want to actuate light, we pass it the correct turn on, turn off. So if the actuate light actually were to depend on multiple switchers spun up, so multiple lights that were connected to. Passing the turn on and off would make some sense and simplify our process. And notice we don't have to get the date, get time, because we're assuming we're using these functions to get those. So our last motion time is now whatever the current time is. Our get time of day is based on the current hours, but we've handed that functionality off. We can check motion detected with the time of day for evening and night, because we just got the time of day to turn it on, and then taking our current time minus the last motion time, greater than 60 seconds or morning or afternoon, we're executing that turn on, turn off that was passed in. Okay, so what does this do to the tests? That's where I think the really cool part happens here. So let's minimize those down and bring the test up. So from the test perspective, we're going to set an an is on variable. We're going to create a turn on and turn off function that we can pass into it. Before each, we make sure is on is set to false. Okay, so fixing side effects, what do we have to do? Okay, so our setup now becomes we set our last motion time. Easy enough to set it to 0. We're going to spy on that get time and get hours and fix the return values. So in this case, 60,000 milliseconds and 1. Okay, so it's past that 60,000. Okay, and since we have a last motion time of 0 and the 60,001, if we looked at that function real quick, what do you think that's going to do? Our get time minus our current motion time, so 60,001 minus 0, which is greater than, which should turn the light off. It becomes really easy to see what that was intended to do. Okay, we passed in a false, and it should make sure that the turn off fired. And we could actually spy on that turn on and determine if it actually worked or not. But we see that is on is set to false. Okay. All right. So, and then in our next one we have last motion, we have get time, we have set hours, we have smart controller actuates lights, turn on, turn off. All of that occurs to make it true. You know, it's still the 60,001, but our get hours is now we're passing it true on the motion to make that work. Notice our turn on and off are only affecting this is on value. Okay. So we're sending that in. We're sending that with the actuate lights. And we take a look here. The motion detected is set to true as it comes through. So it changes the last motion to the current get time, which in that case would be the 60,001. In this case, the return value on get time actually updates the last motion time. So that when we hit this function over here with the get time last motion, it is less than. So our turn off doesn't fire. Okay. Our motion detected is true, and our time of day, because of the 20 value we put in, returns evening, which then would trigger the turn on. Okay, so fairly easy to see what's going on within these tests. A lot easier to understand than the previous example on what was happening with the tests. Okay, and that's the whole idea. We need those tests to be easy to understand and figure out what's going on. So poisoning and code-based side effects. A lot of different things going on in the code base that caused problems in writing our tests. So here we come to a challenging place where we're testing too much. A function that does too many things. Okay, and it's pretty simple here. Okay, we often have functions that have switch statements. They have if branching, and the more you have within the switch, the more you have within your if branch, and the larger the code is, without being refactored, it leaves too many paths through the code to easily test. Okay, so the code for this one is not majorly complicated. And again, I'm going to minimize down to describe here real quick. We've got a messaging class that, and somewhere in here, we're going to determine whether, we're sending an email, sending text, sending queue notification. Okay, and we do that by triggering a message and passing it a user. All right, so in here we're defining a message variable, and based on the user.type, which so we're going to have to assume user has a type. If it's admin, if it's user, if it's an author, we'll set the message to admin message, user message, author message. If it doesn't fit any of those, we get an anonymous message. Okay? Depending on how complex this system could be, there could be more in here, making more paths through. Each of those is a path through. We also have this if block down here that takes the user preferred notification method and determines whether to send an email, send text, or send a queue notification. So here we've got 3 routes through. So potentially you have 4 times 3, 12 routes through for tested code. Okay, testing too much. So here we have a lot of tests. Okay, and if we follow this through, we spied on our messaging class, send email, send text, send queue. We stub those out. So we can check to see which one got fired, right? And then down in the tests, okay, we have admin was sent an email and send the message. Okay, we have admin and let's see, okay, sorry, send email. And I think I forgot to change this, so this should have been admin sends a text with a message. And then this one should be admin sends a queue notification with a message. And here we have user sends an email, user sends a text, user sends a notification, author sends an email, author sends a text, author sends a queue notification. Anonymous sends an email, anonymous sends a text, anonymous sends a queue notification. Okay, that's a lot of tests. That's a lot of complexity, especially when you misspell something. It makes it a little harder to track down exactly where you are in your test suite, right? All right, so how do we fix this? Well, clearly this trigger message is going to have to become something else, right? I can see really quickly that there are ways that we could get rid of this switch statement, have an object with admin, user, author that could be queued up in such a way to determine what the message is going to be, to simplify that whole process. Okay, I can see right down here that we can do something with this notification type and attach a few other things we can do there. Let's take a look at our fixed code and see what we actually did. So I'm going to minimize our test down real quick, but you can see already it's shorter. Okay, we have the same send email, send text, send queue notification at the top. We've pre-built messages. We pre-built one for admin saying admin message, one for user saying user message, one for author saying author message, one for the anonymous to say the anonymous message, which then means that we can build a get message function that just simply takes the type. It doesn't have to be the user.type, it just has to take the type. And based on that type, if it's admin, if it's user or author, it's going to return the message. The appropriate message is off this list. Okay, so if type were admin, you'd get admin message. If it's not admin, it's not user, it's not author, if it doesn't match one of those patterns, it's going to return this messages anonymous. That's how the OR helps us out there. Okay, so the second half of that code that we had been looking at was the trigger message type. And here we can take a type and we can take this message, and based on the type, we're going to send the correct message. So send email, send text. If we don't have email or text as our type, then we're going to send the queue notification. Okay, set that up a little bit differently to check that, but I mean nothing complicated in that checking. Okay, so if the type's not included in the array of email or text, which is why we're comparing to false, then we send the queue notification. Okay, based on that, we can now fire this trigger message, passing it the user. It gets the message from the get message function, passing it the user type, and then it triggers the message type, sending the preference and the message that we just got. Okay, the nice part here is we now have one path through. Now we do have 3 paths through here, and we have potentially 2 paths through here. Okay, so 3 plus 2 is 5, plus 1 is 6. That's half the number of tests that we need. Okay, so what we now see here is we have the same setup. Nothing changed there. We mocked out the same pieces. We spied on the same pieces. Okay, so we expect get message to send an admin. So we pass it admin to see what it does. We pass it user to see what it does. We pass it author to see what it does. We pass it anything else besides admin, user, author. Okay, just to see that we get anonymous back. Okay, so we tested 4 paths through that one. That's okay. And then we test the trigger message for email, for text, and for anything else, which should fire the send queue notification. Okay, and then in our trigger message, not the trigger message type, not the get messages, okay, we only need one route through. Okay, we spy on, get messages, return a value. We spy on trigger message type, we stub it. We set up a user to pass in some information. We trigger the message, passing it to the user. Since we spied on these, we can expect get message to have been called with text, because it's passing at the type, test, since it was passing the type. We can see the trigger message type to have been called with something, which is your notification method, and then the message that we returned here in the previous. We can see that it walked through that code correctly. Okay, so in this case, we don't have to test too much in one of these. While they do multiple things, the number of routes through our code has been simplified radically. So, testing too much. The next one here is one that I see a lot, and this is a bad test double. And I'll admit that at times I'm guilty of doing this and having to go back and fix things on occasion. Okay? So what we have is a service that we mock that's created, and it allows the functionality to be mocked. Okay, so what you end up doing is you created this mock service, and you have to attach each of the functions that are available in the original service, and sometimes you even have to type them upright and things like that. In the reality, the only thing we test when we do that is we're testing the mock itself. Okay, a better pattern for this is to create a mock service from the original service that you're injecting. And then you can spy on and or stub some of that functionality, but you know the original functionality is still there. Okay, we can add our mock data, we can add our spies to the functionality of the newed up mocked service. Okay, so let's take a look at some code on this one. And we come down to bad test double. So in this case, we're going to hide this while we look at our code real quick. We have a data service. Data service has data. In this case, we have fixed data from the beginning, a user of Tom. And get simple is really simple. It returns get data. Okay, so it returns that user object that we see in there. Okay. In our component that we want to test, our test component, we have an API service. This is going to be the data service, I suspect. So our constructor takes a service, it adds that service onto the API service object. Okay. The get data triggers the get simple off that API service. All right, so let's see what we did in our tests that might not be a good way to do it. We create a mock service and a mock result, and we set up for our component. So our mock result is a user object similar to what we have up here with Tom. We're creating a mock service that has a get simple function that returns the mock result. Okay, but that's what we're doing here in the get simple. So when we new up our component and we pass in mock service, we're just passing in this code. Okay. So what happens is when we go to get data, the only thing we're testing is our mock. Period. Nothing else. Okay. So let's take a look at what this looks like fixed. So the top part is exactly the same. The test component, data service are the same. In fact, we have a mock service and a mock result still. We have our mock result assigned to user Bob, just like we did before. But notice we're setting up mock service to be a newed up data service. Okay. We may or may not even need to update this data, but we opted to in this case. We updated it with the mock result, so we have consistent results. If that changed over time, if that data changed, we make sure we're updating that. Okay? And we pass it in this new mock service that's based on the data service. And what we can do now is when we get the data, it's using the get simple from this original data service. So that if something changed in this code later on in that service, this test would fail because, not because test components changed, but because the data service behind it has changed, okay? So you've got to be really careful at where the boundary is on that, on creating these test mocks. There are cases where you need to create a service without basing it on the original. But basing it on the original gives you a lot more leeway in understanding how those two services interact, especially when one is injected to the other. So, bad test double, testing the mock, something to be careful of. Next one we want to take a look at is false positives. Okay, I've seen these occur many times, and I talked at the very intro of this presentation about we had a case where there were 2,000 tests written against promises that weren't failing when the promises failed. Okay, that's what we're talking about here. This can also occur when you forget to expect. Some of the test suites are now returning errors if there's no expect within your test. But asynchronous activity, when a promise that you're testing for the expectation of it to pass, that promise could potentially fail and still not show that it failed. Okay, not break the test. In Jasmine, used to use a done function, and the done in recent certain scenarios has become very unreliable. In fact, it's probably going to be deprecated soon if it's not already, and removed from the Jasmine suite. What we've actually seen and what they've been talking to us about is that JavaScript allowing for async await and try catches makes them much more readable, better to work with pattern, that you don't get that false positive scenario hitting. So let's take a look at some code and see what this means. Okay, so broken false positives. Testable code is really easy. We have a rejected promise. That's the name of the function. Okay, but we're returning a new promise with resolve and reject. And behind a set timeout of 1 second, I'm going to reject that with the word fail. Okay. I mentioned that no expect will also not be a failure. Okay. So this counts as a non-failure. And I say non-failure because there are, like I said, there are some suites that will error because it doesn't have it. Within Jasmine, it tells you that's a pass test. Okay. I'm going to expect within a set timeout of 100 milliseconds that true equals false. Guess what? This passes. It never gets to the expect. It's counted as no expect. And then rejection. So we fire that rejection, and in our then, our result, in this case I checked for failed, not fail. Guess what? This passes. It's a false positive. Okay, so let's take a look at some fixed code in this scenario. Now, same code up above in the testable code. Okay, fixing the non-expect. Guess what? You should put in an expect. Not complicated. Okay, we'll put an expect in. The set timeout one that we had. Okay, what I'm going to do is I'm going to use the Jasmine clock to step past that 100 milliseconds. In this case, I'm going to set a result on the outside of it, change that value inside the set timeout. I step my ticks forward, which allows that set timeout to fire in a reasonable amount of time, and then our expected result comes up true. Okay, I commented this code out, and I want to bring this in real quick to show you something. Okay, this used to be what worked when testing promises for false positives. Okay, we'd pass in this done to our test in Jasmine, and the done is a function, and the function says, hey, we know we got asynchronous activity, and at some point I expect done to fire. Okay, so in our then we can expect the result to be pass, or we can expect the result to fail. When the done fires, that's what told Jasmine the async activity is over. Doesn't work now. I know, I've tested it multiple times. It was driving me nuts when I put this talk together. Okay, so correct pattern. We set up a Jasmine clock. Okay, and I set up this variable that's waiting on the promise. So we actually execute the get rejected promise. Okay, that returns a promise. Okay, so this is the promise that we're waiting on it to finish. We set a clock tick to run past the 1,000 milliseconds. in that case 1010. So the set timeout should have enough time to run. Okay, and then we await that promise to pass. So the big change we had there is the async added up here, and the await added down here to wait on that promise to finish. Okay, what should happen is, because we have a reject up above, the wait is just a wrapper for promises. Because we have the reject, this try catch is going to force it through the error block. And that promise returns the string fail, rejects the fail string that we then can compare against and see that it's matching. Okay, notice outside that try catch I have an expect that result equals an empty string. That will actually pass because that's occurred long before that second was up. Okay? So, false positives, they can be really tricky. If you're dealing with asynchronous activity, my suggestion would be to use TDD. Put your code in a failing state. And by putting your code in a failing state, you can then run your tests to make sure you're not getting false positives. Now, the next two slides, I'm not going to show code. You've seen a lot of code. There is code on these in the repo if you go check. Okay? But excessive setup is a tough one to really show code on, and I didn't want to have a 1,000-line example to show you this. Okay? So we'll talk about some of the issues here. Okay? Seeing excessive setup, seeing something that needs a lot of before eaches or before all, or a lot of code even in the individual test. And I've seen cases of hundreds of lines of setup. Is a code smell. Okay? I'm not saying it's wrong. I actually have had cases where my setup has been fairly complicated because I needed to test things across a boundary. Okay, so where I got away from unit tests and I went into higher level tests. And as you go across those boundaries, sometimes there are weird things you have to do. This is a code smell. This is something where as soon as you see it, we ought to be looking at the code under test to see if a refactor can help. Okay, there are legitimate needs for larger setups. Okay, I just want you to be aware that those lengthy setups ought to get you thinking about the tests that you're putting together and the things that you're doing. Okay. The next one is testing private functions directly. And again, I'm not going to look at code here. There is code. You can take a look. Okay, private code can be tested through exposed functionality. Okay, and even in JavaScript, we now have a hashtag we can put in front of variables within a class to indicate that they're private. Private code can be made public. I've seen folks that have that debate. Do we make it public? Do we leave it private? I've always been of the mindset that for front end, for JavaScript, everything's accessible at some level. There's some way to get to everything within your application. And then the third one, which is another way of doing things, is private code can be abstracted into another service. And by putting it into that other service, because you're injecting that into your current code, that code can then be tested directly, since it has to be public for your current class to handle it. Any one of these solutions is valid. There's no necessarily right or wrong answer here. If your class is inordinately complex, indirect might not make sense. Making it public, some of it might actually make some sense. Okay, so there can be some discussion on that. But the abstraction certainly can be a viable solution for a larger, more complex scenario. Okay, so coming to the end here, unit test recommendations. We talked a lot about unit tests. And we talked about what not to do with unit tests, what to be careful of with unit tests. We really haven't talked much about what to do with unit tests. What are the positives? What are the things you want to pay attention to, be aware of, and do? Okay, unit tests should be readable. Okay, one assert per test method. You can break that one once in a while. I get asked that question a lot. Even in my tests, at times I assert more than once. It's recommended to see if your functionality can be refactored. Okay, because if you're putting in more than one assert, it's possible that your functionality could be refactored more to allow one test per method. There are valid times when it's easier not to abstract too far, and one or two or three asserts is okay. Okay. Avoid test interdependence. Here, I've seen tests that they have to run in a particular order. If you're doing that, then you've got something wrong in your setup of your test suite. And keep your tests short, sweet, and visible. Your code that you're writing, the code under test, you're trying to write these short functions, these little pieces of code, so they become easy to test at the same time. If they're easy, your tests will be short, sweet, and visible. They'll be easy to work with, okay? And make sure your unit tests are added to your build pipeline. Absolutely should be a part of your build pipeline, okay? If your pipeline's not failing because your unit tests are failing, there's a big problem there, because myself as a developer, I try to remember to rerun the unit tests every time I push my code up to get it into the pipeline, but I forget at times. And that build pipeline keeps me honest on it. Make sure I don't forget it, and if I do forget it, and I have a broken test, and make sure we're not pushing stuff through too fast, okay? So as we come to the end here, I do work with Leading Edge out of Columbus, Ohio. And we're hiring. I throw this up. Yay, Larry, here's your big thing. We're hiring all kinds of folks, good folks, folks that love solving problems. Sorry. If you're looking for work, feel free to reach out to me. We'll get you to the right people. Okay. Feel free to check our company out and what we do. We do some really cool things. I love the work that I do every day. It's a lot of fun. Okay. So I am going to close this down at this point on this slide, even though I know you can't directly ask me questions. But we've covered a lot of ground. We've covered a lot of things. If you have questions on the repo, if you have questions on documentation, the slide at the beginning of the deck that indicated my info can be used to give you an idea. Oh, not that one. That one. Give you an idea how to reach me and potentially ask some questions. Okay. Again, the code repository is out there on my github.com profile, Bob-Fornell, and it's what to avoid when writing unit tests. It should be fairly easy to figure that out. You can reach me through Link App. I'm on Twitter at rfornell. I'm on DevTO, rfornell. I'm on LinkedIn, rfornell. And just a quick reminder on that social media project, 100 Days of Code or 100 Devs. Pick one of those hashtags. Go out, find a couple of people, and cheer them on a little bit. Most of those folks that are doing that are relatively new to the tech industry and probably could use some cheering on. Okay? That's my talk. I hope you guys had fun and enjoyed it. And hopefully we'll talk to you all soon. Thank you.